Okay, so for my presentation, I'm going to be reviewing problem 2.29 from chapter 2 of the book, and this is a probability problem where we're going to be drawing chips out of a bag. So the situation that the book sets up for us is that we have 5 red chips, 3 blue chips, and 2 orange chips. We put those all in a bag, and then we're going to draw chips and see how that impacts subsequent chip draws. So the first scenario that we're going to look at is, suppose you draw a chip and it is blue. If we are drawing without replacement, meaning we draw a chip, take it out, see what it is, and then draw another chip without putting that first chip back in. So we draw a first chip, it's blue. What is the probability that the next chip is also blue? So from the above information, we can see that to start out with, we have 10 total chips. 5 plus 3 plus 2 is 10, and 3 of those chips are blue. So if we draw a blue one, we're going to have to reduce the amount of blue chips that are left in the bag. So that's going to take us from 3 down to 2, but also the total number of chips that are in the bag. So that goes from 10 down to 9, down to 9. So that leaves us with 2 out of 9, and if you do that division on that, you wind up at a probability of 0.222. So that is the answer for number 1, letter A. Suppose you draw a chip and it is orange, and then you draw a second chip without replacement. What is the probability that the second chip is blue? Okay, so very similar situation. We take a chip, it happens to be orange, we don't put it back in. Again, our total population of chips is going to go from 10 down to 9, but this time, since the chip was orange, the probability of there's still the same amount of blue chips still in the bag. So that's going to be 3 over 9, 3 blue chips over 9 total chips, and that leaves us with 0.333 to infinity. Our third scenario is, if we are drawing without replacement, what is the probability of drawing 2 blue chips in a row? So we'll just start with the first chip. There's 3 blue chips, 10 total chips. The probability of pulling a blue chip, which is requirement under the scenario, is 3 out of 10, so 0.3. Now, the probability of drawing a second blue chip is actually the exact same situation as item number A. There's 9 chips left, 2 of which are blue, so that's 0.222. So that's the probability, if the first happens, of drawing a second blue chip. So if we multiply those two probabilities together, 0.3 times 0.222, we get 0.0666 to the infinity. And then our last question is a little bit more theoretical. When drawing without replacement, are the draws independent? If we are drawing without replacement, the draws are not independent. And the reason why, as you hopefully kind of saw, was that drawing a chip out of the bag removes that chip from consideration. So no matter what color that chip is, you're reducing the total number of chips, and you're also reducing that the number of that color. So no matter what kind of chip you draw, if you don't put it back in, you're going to change the odds of the next draw. So that would make it, by definition, not independent.